Alright everybody, we're going to try this. I've got my cell phone and a camera mount on a selfie stick so I can video this, and I'm going to try and edit some stuff together with the Apple software. So I had a guy, this is my second Nintendo Switch video, and hopefully this one will actually show me doing something unlike my previous ones. One of these has a stripe on it, that's how I know which one's which, so that's the right screwdriver there. I had a guy on eBay send me this. Pull up the paperwork here. Here's the description. Was working one night, but I put it to sleep. The next morning, I couldn't get it out of sleep mode. It won't charge or power on now, including the power adapter, which I received. I'm not even going to look at the power adapter. I have a Apple charger that has a ammeter on it. And this little device will show me exactly what kind of current it's taking. So let's just plug it in and see what it's doing here. Maybe he's got a bad power adapter. It did switch to the 8 volts. I don't know if you can see that, but it did switch to the 8 volts. And 41 is a good current gauge, so spin this around. Those are good numbers. That tells me the machine is working. Let's see if we get a picture though. Where's that power button on these darn things? Here it is. This is the power button. I have not looked at this, so this is a live repair. I hit the power button. There is no change in current. But it's got the correct voltage, which is, you know, a good sign. But he's right, it looks dead to me. I can't get it to come on, but it is pulling 41, 410 milliamps, and it did switch to the right volts. So that tells me right away there's a couple things going. Maybe the guy bricked it. Maybe he's lying. I don't think he is. I did talk to him on the phone. So these use a special screwdriver, a 1.5 pentel or a 1.5 tri-point. It's different than what you use for iPhones. So I had to special order this screwdriver. An iPhone screwdriver will work, but you'll probably strip out the screws, but you might get them off once or twice, but you'll quickly figure out that you need the correct screwdriver for these. These are long and there's a fair amount of torque on them, so you do have to special order another stupid screwdriver. I don't see the advantage of a tri-point head either, other than it strips easier. So the only purpose for the manufacturer using this screwdriver is to make it a little less convenient for you. There's also a couple little screws on the sides, so you got to remove the middle one. This is a Canon camera screwdriver. I don't know where to buy these. This one came from my grandfather 20 years ago. He used to be a factory repairman for Canon. He worked on single lens reflex cameras, 35mm cameras. Then there's one on this end. I think I have to use a smaller screwdriver for that one. This is a 273. Whatever, I just know it's a little screwdriver. And this German brand of screwdrivers even has German writing on it right there. I don't know, German screwdrivers are good, I guess. Generally anything from Germany is not built because they want to be the cheapest on the block, so I use these little magnet trays. That's where I'm throwing all these screws. It's kind of handy. You don't lose them. One fell out. So that should be it for my screws, except for some hiders. I think we got a hider under here. Or yeah, that one the customer left his memory card in here. Got one little Heidi screw right here. He's got to come out. That's it. So now the case should crack. There, it does. So I'm gonna put this over here, off camera. Now, the outside screws are going to be white, and unlike Apple products, Nintendo actually uses the exact same screw. All these white screws are identical. So let's just go ahead and get these off real quick. And this is kind of refreshing. Usually when I get one of these in on eBay, some gorilla has used a butter knife and a hammer and taken them apart, and the screws are either missing or stripped, lots of things. This is probably the first virgin Nintendo Switch I've seen in a while. Usually when you get them on eBay, they are rough, man. They are rough. Some kids torn them apart before you get them, and they are rough. This little memory tray. It just pops up. There's like a little thing on there. You can just pluck it off. See, little socket right there. I think that's it for the outer shell. Did I forget one? Ooh, I did. That's why you open them carefully. You just don't rip them off. You know, you just slowly pull a little bit and see that you forget one, and I forgot one right there. Let's go ahead and get him. They blend in so well, you know, because they're made of the same reflective metallic color as the shield, so they just blend right in. So they always put a little bit of heatsink compound here to here, just to use the outer shell as a heatsink. So I think that's good. These are actually pretty powerful little computers. These are not just game machines. So if we're getting 0.47 volts, that means right now I know this chip's good. I know this is good. This coil has a history. Well, I put my microscope over here so I can look down on it. This coil has a history of coming off, but if it does, it's like no voltage. It's off. And that's fine. The water indicator's fine. So we don't have water damage. We just have a Nintendo Switch that died. So I'm sliding it around as I look under the microscope. I do not have camera equipment for my microscope yet. So the next step's going to be is just to see if we have any shorts anywhere. And I know this chip's good. I know this chip's good. I know this coil's good. Right off the gate. Okay, so one of the first things you do with these Nintendo Switches, I disconnect the battery right there. And then there's one of the common problems with these machines is a chip that basically runs the display for here. So I will check. Here's the other thing that's tricky about these boards. They're very thermally conductive. So when you heat them, you really got to go after it, one. And two, the vias are not self-evident. So a lot of times on a pad, you can see like a little dimple, and that gives you an indication that it's connected to a piece of metal that is going to go down through the board on the other side. On this board, you cannot see that. I guess this manufacturing process doesn't use dimples. So it makes it for locating the via, especially when you do not have schematics. That makes it rather challenging. But I have found a short. I see this short pretty commonly. Right here on this cap. That is 0.6 ohms. This is dead short. And on the negative side, yeah, dead short. So this cap is totally shorted, but I guarantee you it's not this chip. There's a via. I've learned that from experience. So there's a chip shorted on the other side of this board, I'm almost positive. So now we get to dig a little deeper into Nintendo Switch land. So let's get everything disconnected first of all. I got the battery off there, I got the speaker off here. Let's get this little ribbon out of here. We got a couple more little ribbons over here, and I even use the microscope. I know most people can do this stuff with the naked eye. I just am really comfortable under a microscope doing this. I can see with so much better detail. I prefer using a microscope to put ribbons in and out. I don't want to. I can't see up close as good as I used to. I turned 50 here not too long ago, so my eyesight isn't as good as it used to be. When I was a kid, man, I could read the codes off these little chips like nothing. When I was 20 years old, I used to work on camcorders, Sony camcorders, and talk about a mechanical juggernaut. My goodness, those things had so many little gears and motors, and they were very mechanical heavy. They were hard to work on. Not many people would work on those camcorders. I did them under warranty. We did Sony warranty shop I worked for. So we did JVC, we did Sony, Magnavox, RCA, all those old warranties from the TV days. A lot of shops in the 90s, even though people were starting to switch to disposable, a lot of those shops in the 90s, they still had the old TV warranties from the old days, which are gone now. Used to be, back in the old days, before my time even, repair shops were everywhere. And that's because, so TVs, when TVs first came out, that was like the first major electronic item that needed a repair shop. And they all had tubes in them. And those tubes, they're like light bulbs, they wear out. They don't burn out, but they fade out. The tubes eventually lose their strength, and then the electronics start to have problems. Now, the people who made the TVs engineered them such that even if a tube's output was only 40%, it would still work. But in some circuits, like the horizontal circuits and different circuits, they did not tolerate going down to 40%, and those tubes would fail. So these TVs were expensive. To put in perspective, I have a 1940, man, I can't remember now what year it was. I got the first RCA color TV made. It's a RCA CTC2, or CTC, I think it's a CTC1. And it's the first color production TV RCA made. When it came out, it was like $1,000. So $1,000 in like 1952 was a lot of money. I mean, that's like $10,000 a day. When these TVs first came out, they were not inexpensive, so they needed repaired. They would get fixed, and the TV shops needed people to fix them. And because they were so expensive and they needed fixed and they broke a lot, especially when they got older, or in moving, those tubes would come loose and different things would happen. So every town had a TV shop, and you could even buy the tubes. You could go to the local drugstore, and there'd be a tube station there with a tube tester, and people would take the tubes out of their TVs, bring them in, and put them in these sockets in these tube testers, and they'd see if their tube was good. And then if it wasn't, they would go buy a new one right there on the shelf, and the customer would replace the tube. And when you take the back off the TV, it showed you where all the tubes went, and the schematic was right there on the TV itself. You know, boy, things have changed. Now the schematic is unobtainium. It's a corporate secret, and you're on your own. Nintendo doesn't help us fix these things at all. Well, they go out of their way to make sure we can't fix them. Ordering proprietary chips from vendors with exclusive contracts, so we can't purchase those chips. Nintendo pretty much is, and they've done this from the early days. I remember, 90s, 2000s when I was working on those NES systems. Remember, you'd have to blow on the cartridges because those connectors always sucked and they broke. They did it back then. That's kind of when they started with the special screwdriver that you had to order. Now we have the internet, so if somebody does something wacky with a screwdriver, there's 50 guys on AliExpress selling it for $3, so there's no point in even trying to keep somebody out of something with a screwdriver anymore. But don't mean they don't keep trying to do it. I guess it keeps the consumer out, so if you get water in your machine, you can destroy it because you can't open it to take the battery out. I guess it's effective there. And you see that a lot. So I think we've got all these screws out. This jack has to come up and out that way. So let's get the board up on this end. Just gonna have to be careful, looking and kind of wiggling, making sure you got all your little wires off. There we go. This chip here is most likely my culprit. And this is most likely where the cause of my short, based on my experience. I'm going to see if this cap here is shorted. Most definitely is. So I'm gonna just make a wild assumption off experience here, since I have schematics not. And we're gonna just float this chip off of here. I'm gonna start preheating my hot air station, so you're gonna hear it running. I'm gonna dial this up to 450. This thing needs a lot of, it fights the hot air, let me tell you. So when that gets hot, let's go ahead and put some goo on there. Maybe I could actually adjust the camera so you can see. Let me clean the lens. It looks like it's got a glare on it. It helped a little bit. So I can adjust this so you can see what I'm doing. There's that chip right there. Hot air is still heating up. I'm going to go ahead and get me a replacement chip out of the drawer. These aren't the cheapest chips in the world. I have a few of them. Tighten up my orientation here. Switch to foot feet. So I'm on foot feet now. Let's go ahead and get this sucker off of here, because I'm pretty sure this is where my short is. Probably ESD zapped it plugging it in and out of the docking cradle. I've seen this chip. This chip probably fails on 20% of the switches I see, which is kind of high when you think about that, but I think they probably could have done a better job of protecting this IC with some buffer circuits, some surge protection. I don't see any of those Zener clamp surge protection circuits anywhere around this thing or that dock. Apple's always been really good about that. So I don't know if you can see that on the camera, but I'm looking for the shine. Okay, I'm starting to get some shine. Those pads are starting to pop. I'm starting to get some shine. The ground planes are going to be the last to go. They're going to be the fighters. Alright, so we're shined up. Let's take you off. Awesome. While you're hot, let's just put some more juice on you and put you on. Where are my other little pair of tweezers? I always seem to find a hair at the worst possible times. The last thing I want is a hair under this chip messing with a flow, so there we go. Need 2 sets of tweezers with 2 hands. Alright, before I drop this down, I'm going to check really quick to see if I'm barking up the wrong tree. Let's see if my short is gone, where I just put a chip on there. My short is definitely gone, so that chip is my cause. Let's put her on. Pretty common failure, this IC. And I am not going to take this solder off and put lead-free solder on. You know, I don't care about, I actually prefer not using leaded solder on. I'd rather just use what came with the, oop, thank you, hot air station. Blowing off my chip. I gotta make sure my orientation is correct. Let's get you hot. There's plenty of solder on all these little guys, so I don't feel a need to reinvent the wheel here and wick all this off. Put leaded solder on there. It's probably best to avoid leaded solder altogether. A lot of times if I can just reflow apart and leave the lead-free solder on the board, that's exactly what I want to do. I know it's a little hotter, but that doesn't hurt anything, as long as you're controlling your temperatures carefully. But I mean, it's definitely true that leaded solder is easier to work with because you've got a 100-degree window of lower temperatures. All right, let's put this little turkey back on. I want enough flux around it to where air won't get under it and it'll get flipped off. Because that's what'll happen if there's an air gap between it and the board, and the hot air get underneath it and just blow it right off the board like you saw there before. I see it starting to bounce a little bit. There, I got some flow. Getting some shine on a few pads here. Once these all go, I'll be able to tap it, make sure we're centered and we're down. There, it looks like everything's going. Let's see. Backing off a little bit. I want to keep it just hot enough because this chip isn't going to snap. It's going to require some touching, so I don't want to overheat it. So I kind of keep a little safe distance with the gun and kind of move in and out. Yeah, this chip is sucking to the board. It's not floating very well. Okay. These Nintendo boards, boy, they just love to suck up that heat. Pretty sure we got a really nice flow. So there's two ways to control temperature. One is on the gun itself by going over there and hitting the buttons. The other is to move in and out while you do it. And realistically, that's the only way you're going to control temperature, is to move in and out. So this is good. Looks like we're fixed. I'm going to let this dry. Get my little heat shield and put it away. And this is our defective chip. See if we can see any physical damage on this. Just for my own morbid curiosity's sake. I do not see anything there that would indicate that it's cooked. You know, it looks perfectly fine. Some of these, they blow, they get hot enough you can actually see, you know, cracks or bubbles, but there's no evidence of that in this one. So it's definitely the cause of our problem. So our short is gone. I'm going to go ahead and cool this board just a touch so I can clean it. When I change a chip, I don't like to leave a trail. Someone follows me and wants to see what I changed. I want to do such a good job at it that you can't tell what I changed. You don't know. Pretty happy with this flow, even though I had to manually position it a little bit, which is a pain. The flow came out real nice. And I was careful to back off of it so it didn't get too hot, and I just pulled the gun away to keep it just above the melting point so I could move the chip, but at the same time not over temp it. Chips are pretty rugged. But if you have your hot air gun set to maximum because you think you're in a hurry, I mean, that's just like someone who sets the thermostat on the house to 90, thinking the house is going to get warmer faster. You know, it's just the same. This is the same thing I'm going to talk about here. When you have a hot air station and you set it, and you should calibrate your hot air station so you know where you're at too. I mean, when I say calibrate, I don't mean make the display come up exactly like the temperature. I mean learn what number on the display really means for temperature. Because that display is kind of irrelevant. I mean, well, yeah, one guy says he sets his for 600. The other guy says 300. The other guy says, I just crank it to max. I don't know what it says. You know, that would be Louis Rossman, because he works on shit a lot bigger than this. It doesn't matter. But realistically, you just have to learn your machine. And your gun's going to change a little bit over time. This Weller, this WHA 3000, has been very solid. I've used it for the last year now, year and a half, and I haven't noticed any change in the gun's head or temperature or any of that stuff. But a lot of them, they will tend to change over time. And if you look at mine, I've got different stickers on it for different temperatures I've figured out for different devices, you know, things that I know work good for me. So, but back to my original discussion here, you don't want to just take your hot air station and crank it. That's not the purpose of it. You know, you want to learn where things melt and learn how much heat is going to be sucked out of that board, and then learn where to set and how close to hold your air. There's a lot to it. It's not complicated, but most of it's going to be by feel. You have to feel where your equipment's going to be, and you have to feel it. So, I mean, that's kind of the big thing there. But don't get in the mindset of turning your gun up to its highest temperature so that you can get it hotter faster. That doesn't work. If you do, sure, you'll get things hot, and when you hit on the chip, it'll liquefy quick, but then it'll quickly race past your desired setting, and then you're going to be in break stuff land so fast your head will spin, and you're going to run into problems, and your flux will burn. It just do what I do. Find the temperature that works for what you're working on, and then don't go crazy. You know, preheat your gun, which is what I did. If you notice, while I was getting the chip, I had my gun turned on, and just easy peasy. You do not need to smoke these little things down. And if you work on them for a while, you will learn that as you break them. That's why you don't want to practice on customer equipment. You want to practice on junk you buy on eBay, which for this particular device, that's what I've done. I bought some on eBay, and I figured out how to work on them. And I'm sure I broke a couple. I learned what my temperatures need to be. I experimented with where different circuits were. And I've got a couple, you know, in the last several months. I do these on eBay, and some of them can't be fixed. I get people that send me units that have been, you know, they've hacked the firmware on them so they can get free games and stuff like that. And if something goes wrong while they're flashing the firmware, or they screw up, and it's because they're watching some video that's a month old and out of date for what they're currently doing, they end up trashing their machine. They brick it, and it can't be fixed. So then they sell them on eBay. And then after they sell them on eBay, some kid buys them, sees my ad, and he goes, "Oh, I sent it to this guy." So he sent it to me, and I quickly figure out that the problem is that the CPU is bricked, because the firmware is actually in the CPU. Thank you for Nintendo for making these impossible to work on, which is totally intentional. And then it can't be fixed. So I've ended up with a couple boards, just because, you know, I tell the guy, hey, you can't fix it, it's been bricked. And a lot of times they just say keep it, which I really appreciate, because I waste my time finding out they're sending me a device that is not going to be fixable. And you know, at least they give it to me so I can steal a chip off of it or something. There's a little lip here. It's always tight getting this in, so that's what I was fiddling with there. these little Nintendo switchies. Messing with these little connectors. Get in there. I'll have better camera gear eventually instead of using my phone, and these will work out. I don't even know if the camera can see me doing these, to be honest with you. I'm just looking through my microscope. But yeah, so on these switches, you're going to see some bricked ones. Usually it's going to be that chip I just changed a lot of times, or it's going to be this, there's a coil here that pops off. This gets cooked. Don't see this one die too often, but I have. These break a lot, and you see people try and change these on their own, and they just dig them up. So like you see these pins here, you can see on the inside in the middle is a whole nother row you can't see. These are not, changing these USB-C connectors on these Nintendos, these are not for beginners. I just wanted to go over real quick what is the correct amount of heatsink compound to use. So many people overdo a thermal compound. It's a mess. So I'm going to show you really quick what I believe to be the correct amount of thermal compound. So here's the purpose of thermal compound. Thermal compound fills any gaps or air spaces between the heatsink and the actual device. And the reason that's important is because air is an insulator. It doesn't conduct heat very well. So you want just enough thermal grease in between your two plates to fill up any gaps. That's it, microscopic gaps. And you can see that it's got little dimples on it, right? Well, if I peel that off, that's the chip underneath there. That's just a little copper sheet. Now I'm going to scrape off the rest of the thermal compound on this guy. So you can see it's not perfectly smooth. There's going to be, you know, little scratches and stuff. So you need some thermal compound to fill up the space so we conduct heat. You don't need much, people. Less is more. So this is the area that needs the heat. So let me show you how much I'm going to put on it. That is probably too much. I'm definitely a slob with it. So let's clean that up. And a lot of thermal paste, especially the silver ones, which this one is, they're the more expensive. They will conduct electricity. They will be a conductor. So you see people using this thermal compound, and let's see, look, there's not much there, but I'm going to put this on. I'm going to get it on there. I'm going to slide it around. Then we're going to take it off, and we're going to look at it. See that? We covered pretty much the whole flat area of the chip, and I didn't even screw it down yet. So that's plenty. That is plenty. You do not just goober this stuff on. It's not only wasteful, because good quality thermal compound is very expensive, especially stuff that has silver in it. But it's just stupid. I mean, I see people, inexperienced people, put thermal grease on stuff, and it's just a damn mess. You don't need to wrench these either. You just need to snug them. And this stuff here is some of the grease that's on the lid. And I will harvest some of this. Make sure it's on this copper heat tube. These copper heat tubes are fascinating. They're basically air conditioning radiators. They have Freon in them. and they are so good at conducting heat. This Nintendo Switch isn't very old. It's fairly new because this compound is very pliable. It's very good. Otherwise, I couldn't reuse this. But it's very soft and gooey, so I'm reusing it. I would say Nintendo used too much thermal compound, wouldn't you guys? They used more than they needed to. I have a special rag whose only job is heatsink grease, because boy, that stuff gets everywhere. Gets on your bench, gets on your fingers. So I have a special towel whose only job is to clean that stuff up. And then when it gets nasty enough, it goes in the washing machine and I do it again. I even got to clean the insides of my tweezers. So that is the appropriate amount of thermal compound. And as you can see here, with that little extra I put on, I put this back on and tighten it down, and then it'll make thermal conductivity to this plate too. That'll help. I don't think this is required. Really what's required is the heat pipe, but it's always nice to have a little more, and the manufacturer thought that as well, and they went ahead and put some there, so I will too. So that's the thermal compound. I'm going to go ahead and assemble the rest of this madness off camera, and we'll try it again when it's all together. So I've got the Nintendo back together, and now I'm actually using his Nintendo charger, which shows up at 14 instead of 8 like the Apple charger does. But the chip's cool with that. It's happy with the 8. It'll run it just as well. You'll just get a slightly lower current reading, because voltage times current equals amps or equals watts, and so the current times the voltage equals the wattage. So the machine's still taking the same amount of wattage, but you do the math, it's a little different because we're at 14 volts instead of 8. But it is charging, so I'm just going to let this continue to charge. I went ahead and cleaned it. You can see the reflection of my TV in the background and different things. This is that chip you saw me replacing on video. I'm going to go ahead and save that for the customer and give it back to him, just so you can kind of see. I told him I'd make a little YouTube video as well, because my last video really didn't go over any actual repairs. It just kind of went over, here's the machine and yada yada yada. I'd like to have a little better video, so that's the purpose of this one. So this is a successful repair. I will come back to this maybe a half hour or so once the thing is charged up, and I'll show you the full screen coming on. Okay, I've let the unit charge for a little while. It's actually pulling a little bit less. I think the battery's pretty much charged. I'm going to go ahead and see if it turns on completely now. Sure does. And it actually does show that the battery's almost completely charged. And you'll notice that as the battery approaches a full charge, it will start drawing less current. So we're fixed. This guy has a good working Nintendo Switch. The problem was this little chip here, which handles the switching for his video. This chip actually switches the video in and out of the USB-C port when you're using the dock. So the only thing I can think of is he had maybe a defective charger on the docking station, or it got ESD struck. These actually do not have enough surge protectors around them, like I see in Apple devices. Apple uses these really high-speed diodes that will short, spikes to ground and stuff, and I just don't see that inside these machines. So you have to be careful with them, I would assume. But successful repair. And this is my first video that I've edited with iMovie, Apple iMovie. So this is my first edited video attempt. And I do have a cold, so you've probably heard me making some snorting noises or other things in this video. I'd like to apologize for that. But this actually shows you some of my handiwork while I'm actually doing it. I actually went back and looked at some of that video and putting it together right now. We'll be throwing it up on the YouTube channel probably in the next half hour. I was pretty pleased with it. Using that camera while I work through the scope actually does work. So I'll probably be making some more videos like that while I'm still waiting on some camera gear. But thank you. This is a successful repair. This guy has a working Nintendo Switch. and we're in good shape.